and I know I sound like a broken record. I will always sound like a broken record. Every time we are given an equation, we're going to ask ourselves, what type is it? Because we have great chances of solving it correctly if we know what type it is. So what is it? What type?
Terms I just saw.
It is a linear equation, very important. The terminology is extremely important. Why? It's because we have to have a way of communicating. And without knowing what type of it is, you cannot just simply solve. Later on, you'll see there are so many different other types of equations. And without identifying it correctly, you will not know how to proceed. So this is a linear equation. It does not have x in the denominator, and we only talked about two so far. Rational with x in the denominator and linear without x in the denominator. And there are other characteristics. Has to have power 1, the degree has to be, and so on and so forth. So we know it's linear. Now I see 3 denominators. I see 9, which in prime factors is 3 squared. I see 1, I shouldn't even mention it, and I see 2. I need to find the least common denominator. The least common denominator, because my purpose is to eliminate fractions. So the least common denominator has to have all different factors we see here. I only see 2 and 3. 2 has power 1, it will stay with power 1, but 3 has power 2, and I have to choose power 2. I have to choose the highest. And 2 is the highest. So 2 times 9 will be 18. So therefore, in order to eliminate fractions, I will multiply by 18 over 1 each and every fraction, each and every term, whatever I have. But I will not multiply, but I will simplify first. So 9 divided by 9 is 1, 18 divided by 9 is 2. 2 divided by 2 is 1, 18 divided by 2 is 9. And now the new equation is 2 quantity x plus 6 equals 18 times 3, 54, minus 9 quantity x plus 2. Any questions so far? Is this okay, everyone? Questions, please stop me anytime. Anything? Okay, so this is 2x plus 12 equals 54 minus 9x minus 18. It is recommended to simplify both sides. I see cell phones, and I thought we discussed that. Yes?
I'm sorry, I have a question. Why didn't you cross the 3 and 8? Why is that not so?
18 divided by 1 times 3 over 1 is 54 over 1. Yes, it's not top and bottom. Very good question. Thank you for that. Okay, 2x plus 12 equals negative 9x plus 54 minus 18. I think it's 36. Correct me at any point in time. Okay. Only now I recommend moving terms around. You don't have to do it in one step. I recommend it in one step because that's the easiest thing to do. But if you want to write underneath and move terms or add and subtract, please, any questions? Go ahead. Go ahead. Any questions? You may help me, and you may help everyone else. Every now and then I get a question that really makes me think. Like, it happened one time about 2 semesters ago. A student asked me, what's the connection between this and this? And I said, how come that I did not present that connecting these two topics? I never thought of presenting them connected, but I do ever since. So if you have a question, you may help me improve my presentation. Okay? So you are helping me, and I'm hoping that I'm helping you. Okay, so I'm moving 9x. It will become positive. Plus 2, it will be 11x. And I'm moving 12 to the other side. It becomes negative, and 36 minus 12 will be 24. So therefore, x is 24 divided by 11, and no one can simplify this further. Is this okay?
Yes.
Every step? Any questions?
Yes.
Please.
So when I was doing it online, it was saying to make sure your answer is right, to plug it in, correct?
Oh, you want to go back and check?
That's what I did, and I was not getting it.
Did you get 24 over 11?
Yeah, but when I plugged it in, it just wasn't adding.
Oh, we'll check. We'll check. Let me. Maybe there is something I haven't noticed. So let me double check everything, and then we'll go back and plug it in. So you did get 24 over 11. Okay, so let me check again then. So this is 2. That's 12. That's correct. That's 54. That's 18. That's 11. And is 54 minus 18 36? Is 36 minus 12 24? Okay, very good. So now let's check. So we have to check 24 divided by 11 plus 6 over 9 and see if it's the same with 3 minus 24 over 11 plus 2 over 2. So I took this side and I replaced x by 24 over 11. This is here. And I took the other side, 3 minus 24 over 11 plus 2 over 2. If this turns out to equal this, then I'll go back and say that must be true. Are you with me, everyone? Who understand what we're doing? Excellent. Very good. So then, the least common denominator is 11. The numerator needs an 11, as we know from the previous experience. So we have 24 plus 66 divided by 9. Well, 24 plus 66 is 90 over 11. Is that correct? Always correct me. Divided by 9 over 1. So now the numerator is 90 over 11. I flip the denominator into 1 over 9. So 9 divided by 9, 90 divided by 9. So the simplified form is 10 over 11. If I get from here 10 over 11, I'll go back and say yes. If from here and I do not get 10 over 11, then I'll say I made a mistake here, and this is not the correct answer. Okay, so let's check the second half, the other side, the right-hand side. Okay, so 3 minus, again, the least common denominator is 11, so 24 plus 22, because I have to multiply by 11. Everything divided by 2. So this is 3 minus, so this is 46, is it? 46 divided by 11 times 1 divided by 2. I will simplify and get 23. So now I have 3 minus 23 over 11. The least common denominator, it must be 11. I have to multiply the top by 11. So this is 33 minus 23, which is 10 over 11. I get the same thing. Yes, yes. This must be true. Any questions? Is this clear now?
Why did you put 11 as the numerator? Or like the same with the 24 over 11 and then 11 over 6?
You mean from here, here? Or from
No.
here, here?
From 24 plus 22 over 11 over 2.
Yeah, so I add, this is 46 divided by 11.
Yeah.
This is 2 over 1. A fraction divided by another fraction. I copy the fraction from the top like I did here. I copied the fraction from the top and I flipped the fraction from the denominator. So this is the fraction from the top and I flip the fraction from the denominator into 1 over 2. And I simplify. That's how we divide fractions. I keep the fraction from the top and I multiply by the multiplicative inverse of the denominator. Yes?
Can you please calm down? Please. From the last equation, I think
From here?
Yeah. 2x plus 12. I think you collected the like term, right?
But these are not like terms.
No,
2x and 12 are not like terms.
Yeah, I know.
54 and negative 18 are like terms. That's how I get 36.
We moved 9x
Negative
together.
9x to the other side, it becomes positive.
Then what about the 12?
It becomes negative. 36 minus 12 is 24. Right? It's positive here. I have to move it to the other side. It becomes negative. Like this one was negative, when it goes to the other side, it's positive. So 36 minus 12 is 24. Is that okay? Yes? Other questions? Is everyone okay now with this? Anything else? Is this okay then? Good. Moving on. Do you have other questions for me? Okay, method number 2 then of taking square roots. We are still in 1.5. We're still in section 1.5, and we're looking at the second method of solving quadratic equations called taking square roots. Okay, first of all, let's see when is this applicable. This is applicable only in a situation like this. On this side, we see an expression that has x in it, and it's squared. On the other side, we have just a number. That number can be positive, negative, or 0. But this side has to have x, and there is no x on this side. Okay. Then we will take the square root from both. So the correct answer on the left-hand side, but we haven't talked about it yet, is the absolute value of x. It's not plain x. We will talk about this in the next section, 1.6. The square root of 4 is 2. I want you to make sure you understand that the square root of 4 is not plus or minus 2. Please do not ever consider that. The square root of 4, I mean, this is correct because I put not equal to. So the square root of 4 is 2. However, what does this mean? What does this mean? So this is the absolute value of x, which means the distance from 0 to x. So the distance from 0 to x is 2 units. Can you give me the answer? What are the possible options? Positive and negative 2. But the positive and negative come from this, not from the square root of 4. I want you to make sure you understand that. So this equation solves, when we solve this equation, we get positive 2 and negative 2. But the positive and negative come from here, not from 2. In general, the principle of taking square roots, in general, we write x squared equals k, a number, positive, negative, or 0. And when we take square roots, we omit this step. That's how my students get confused, and they say that the square root of 4 is plus or minus 2. It's not. The plus or minus come from this side, not from that side.
That's because you can't take a square root of a negative number, right?
It's all about the square root of x squared having a result that is positive. I can have x to be negative 2, because when I square negative 2, I get 4, and the square root of 4 is 2.
Oh, yeah.
So it's more about the result, the outcome. But you're right. Also, under the square root, I have to have positive or 0. Correct. Okay, so I'm choosing, if you have your book, please, I will let you choose whatever problem you want. We are on page 167, and 15 through 34. But I don't want to spend too much time waiting for you to choose. So if you want to choose quickly, I'll be very happy. So between 15 and 34 on page 167. I count to 3. If you have any question, I'll wait. If you don't, I'll pick. Okay, 1, 2, 3. I'd like to look at 22. 22 is x minus 3 squared equals 36. So now the question is, can I apply the square root property for taking square roots? As long as this side has something with x and squared, and the other side has a number, no x and no other terms, just one term, one number, the answer is yes. So let's take the square root from both sides. I forgot to ask you, what type of equation is it? We know 3 types now. Exactly. Very good. It's quadratic. We know linear, quadratic, and rational. It is quadratic, of course. How many solutions will you always write for a quadratic equation, even if they are the same? 2 solutions, right? Degree 2, 2 solutions. Please make yourselves a note. Every time you identify something like this, just make sure that you remember you have to write 2 solutions. And the left-hand side should be the absolute value of x minus 3. Instead, we do what? And you will look at this and you'll tell me what to do. Yes? Exactly. That's it. Awesome. Of course, we move 3 to the other side. And we have no choice but to simplify and separate these solutions. So one is positive 9 and the other one is negative 3. And this is the square root property, or the principle that we just applied. Feel free to choose another. I'd like to present one more problem. If you don't choose, I will. Which one?
I said 3, 2, 1 point.
Which one?
I said 3, 2, 1 point.
3, 2, 1.
Yeah, you're never mind.
Okay, what about 25? Oh, you already counted. That's what it was. Okay, I got it. It took me a second. Good. Okay. Is this set up? Is this equation quadratic? Is it set up so that we can apply taking square roots? Of course. Now, by the way, of course, it's the same thing.
I meant to negative 16.
It doesn't matter. It can be 0, positive, or negative. Same thing. So here's a question for you. Assuming I want to expand this, can anyone give us the form? We will not, but I want to test you now.
X plus 3 times x plus 3.
We have a formula. We are not foiling. If you want to foil, that's fine.
X
But
squared,
yes,
3x plus 3x plus 3x plus 6x plus 9.
exactly. This is what I want you to have in mind. If you're not, you're already behind, by a week behind. We talked about this on the first day of classes. Perfect. Of course, we're not going to expand because this is already set up for taking square roots. The left-hand side has something with x and it's squared, and the right-hand side is just a plain number. So the left-hand side will be x plus 3. The right-hand side will be,
Plus or minus.
of course, excellent, the square of negative 1 times the square of 16. And we know what this is. How do we call it? Very good. The imaginary unit. Awesome. And the square of 16 is 4. So x equals negative 3 plus or minus 4i. There is no need to separate them because we can simplify. Any questions? Any questions?
So when there's an I, you don't add or subtract, you just move it over and later on.
They're not like terms. If this one were negative 3i, I would have combined them.
And anytime it's negative,
When you take a square root of a negative number, this is negative 1 times the square root of whatever. Yep. Any questions? Any questions? Okay, let's continue with the next method. Method number 3, completing the square. Completing the square. A few minutes ago, 1 minute ago, I asked you how to expand this. And you correctly identified the x squared plus 6x plus 9. Because we know that a binomial squared is, very good, awesome. That's all I wanted you to say. That a binomial square is a trinomial. Okay, I'm going to choose a problem to complete the square for. And we'll discuss it step by step. Let's say problem 50. We are on the same page, 167. X squared plus 4x equals 12. I know you must be still thinking or wondering, why 4 methods? I will explain. I'll get to that in a minute. After we finish this and we look at the 4th method, and then I'll explain why 4 methods. Okay, so see this situation. If you look at this binomial squared, and we got, when we squared it, and we say we expanded it, we got x squared plus 6x plus 9. So now if I ask you, if I have x squared plus 6x, what should I add? What is the 3rd term that I need in order to complete the square? I have 2 terms, and I'm missing the 3rd one.
The 9.
Exactly. How did we get that 9? Here's how we get it. 6 divided by 2. What is it?
3.
Because it was a 2 in there in the formula, right? And 6 divided by 2 is 3, and now let's square 3. Okay? That's the method of completing the square. So now what is the middle coefficient here? Don't even look at the last term. We don't even care for it. 4. If you divide 4 by 2, and you square that number, that's exactly what we need to add to both sides. But I want to write these steps down for everyone. In step 1, identify the middle coefficient. And you did correctly. You said it's positive 4. In step 2, I asked you to divide it by 2. And you did correctly. And you gave me 2. In step 3, I asked you to square this number from step 2, and you correctly said 4. And in step 4, we add 4 to both sides. Be careful, we cannot add it just to one side, because remember, an equation is a balance. If I have 1 pound in each hand, if I add 9 pounds here, I destroy the balance if I don't add it here as well. Yes, please, right?
Why wouldn't you just subtract 12 from both sides and make it equal to 0? Isn't that the goal here?
No. But you're right. It is the goal when we get to the 4th method, but it's not the goal now. But it's a very good question. Okay, so we're adding 4 to both sides. Remember, we must add to both sides. And now I would like you to give me this, because I know the right-hand side is 16. We factored last time. We used 2 sessions to factor. So x squared plus 4x plus 4. What is it? If we still FOIL, we're going to have difficulties in factoring. So what is it?
X plus 2 squared.
That's all I needed. So now what is the problem with this method?
It's such a roundabout way to do it.
Say it again.
It's such a roundabout way to do it. It's more efficient to do the other one.
So what is the problem with this method? The problem is that it alone does not solve the problem, does not solve the equation. Now I have to use what? Taking square roots. So then the question is why? Why do I even talk about completing the square and solving quadratic equations? It works sort of like this, right? But instead of this. But it's a very important method for something else in this chapter. So we need it. Will I ever, if I encounter a quadratic equation, will I ever think of solving it, completing the square? No, ever. But if you ask me to, then I have no choice. If I get a test in which you say, you must solve this equation by completing the square, I have to show that I know the method. But will I otherwise ever solve a quadratic equation using completing the square? Absolutely not. Absolutely not. Because as you see, after all this work, it doesn't even solve the equation. I have to go back to method 2. So let's finish it up. This is x plus 2 equals plus or minus 4, or x equals negative 2 plus or minus 4. And yes, we have to separate them because they can be simplified. So we get negative 6 and we get positive 2. See the difference? See why we needed to complete the square and we needed to add 4 to both sides? Yes? Please, is that okay? Yeah, we needed to complete the square. Now, of course, this was a nice problem because this number was divisible by 2. But if it's 3 or 7 or 5 or 11, it's not going to be as nice as this one. So let's look at one such example. Let's say 58. 58 is x squared minus 3x minus 5 equals 0. Can anyone walk us through the steps? First step is identify the middle coefficient, which is negative 3. Second step, we divide it by 2, so it's negative 3/2. And in the third step, we will square this number. When I square a fraction, I square the top and I square the bottom. What do I get? Excellent. This is what I add to both sides of the equation. And at the same time, I will move 5. So the new equation is x squared minus 3x plus 9 over 4 equals 5 plus 9 over 4. Please remember, it must be added to both sides. Now we know factoring and we know what happens on the left-hand side. And on the left-hand side, this is what? Exactly, what we squared to get that. Of course, of course, of course. Well done. Now the right-hand side, I need the least common denominator and I need the adjustment. 4 times 5 plus 9. Okay, after all this effort, I'm not done. Completing the square alone does not do the job. What do I need to do next? I have no choice but use the previous method. In the previous method, the square was already completed. Here I have to complete it before I take the square root. So then I have x minus 3/2 equals, remember it's quadratic. Very good, awesome. Plus or minus the square root of 29 divided by 2. No one can simplify this. I will not separate it, but I have to move negative 3/2. And this is the method of completing the square. Very important for something else. I can tell you it's for the equation of the circle. When we get to it. Yes, please.
Can you please go through, so once we figured out that minus 4,
Yes.
and we added that in,
Yes.
to get the, why did we plug in the negative 3 with 2 again?
No, we factored using the special product that we discussed on the first day. This squared is the first term squared minus 2 times the first times the second plus the second term squared. This binomial squared has 1, 2, 3 terms. That's why I insisted, and of course I can't force you, I insisted from the first day of classes to understand that this binomial squared has 3 terms. First term squared minus 2 times the first times the second, which is this, plus the second term squared, which is that. Can we continue foiling? Yes, but we're going backwards instead of moving forward. So please make the effort. It's just 3 formulas, really. Okay? Any questions on this method? Any questions? Questions?
So
Yes,
it
please.
might not be a question, but like, so when we first started it, when you say you're going to add the 9 over 4 to both sides, you also mentioned putting the 5.
Yes, because I want on this, I don't want anything else left over on this side.
So could the first step, if it's more
Sure.
comfortable for you, just to do that first? Because that's just how
It's an extra step. We can do it in 1 step or we can do it in 2 steps.
Okay,
So you want to prepare this like the equation like this.
correct.
A plain, clean, perfect squared and a number on the other side. So that's why we have no choice but move -5
Yes.
eventually.
Yeah.
At the beginning or at the end, it doesn't matter. Perfect questions. Anything else? Is this better?
I don't know, I think it's just because of the fractions and throwing me off, because I usually do get it, but I think
But you understand that the binomial squared is 3 terms, correct?
yes.
And we understand that this formula is the first term squared minus 2 times 3/2 is minus 3. 2 over 1 times 3 over 2 is -3 times x plus the second term squared.
And we're just shrinking that back.
We are factoring it. So this is the special product from the factoring from last week, in which we apply the special product. I saw that 1 second. When we apply the special product, that is this. Yes, please. When we add fractions, we change this into 20 over 4 plus 9 over 4 to get 29 over 4. This is what we did in rational expressions. Please remember, this is extremely important. Is this better? Yes, everyone? Okay. Last method. Method number 4, quadratic formula. For the quadratic formula to be applicable, the equation must be set up like this. Descending order polynomial on the left and 0 on the right. If I don't have this situation, I cannot use the quadratic formula. And the quadratic formula is
X equals negative b plus or minus squared of b squared minus 4z all over 2n.
excellent. I could have not said it better.
It's good memory.
It's the best I've ever heard. Excellent. Now, before we pick an example, I'll pick an example. Let's say 68. X squared plus 5x plus 2 equals 0. I'm going to say this. In the same way, create a tune for this, and you will be happy, right? First term minus the second term squared is the first term squared minus 2 times the first times the second plus the second term squared. In exactly the same way, we have a song for this. Just create your own. Create your own song for this and it will stick forever. And you will never ask, where does that 2 come from? Right? Because we know where the 2 is coming from. Blaze told me he had something to leave. That's why he left early. Okay? Good. So, before we attempt this to just plug in A, B, and C, I want to talk about these 4 methods. When do I use which method? Which one is applicable when? From these 4 methods, only one may fail to be applicable. Which one?
Last one. Yes. Last one.
So let me review. Factoring, taking square roots, completing the square, quadratic formula. Which of these 2 may or may not work?
Factor.
Of course, not all polynomials are factorable. All the other 3 work perfectly in all situations. No matter what it is, you can apply those 3. You can always complete the square, you can always take the square root afterwards, and you can always use the quadratic formula. Now, when do I use which method? If you're giving me an equation and you say, quadratic equation, and you say, solve it. My first thought is, if I need more than 15 seconds or 20 seconds to factor, I'll say forget it. I'm not going to waste my time. The second method I look at, see if it's a perfect square with x in it and just a number on this side, taking square roots. Will I ever complete the square? Absolutely never. If you just say, here's the equation, I'm not going to tell you which method to use, then this is what goes through my mind. Factor, if it takes 20 seconds, otherwise forget it. If it's in the format of the square, something squared with x in it and a number, I'll take the square root right away. Complete the square? Never. Quadratic formula, when I have no choice, I can factor. It's not in a perfect square format. then I'll use the quadratic formula. Does it make sense? Should I repeat this? So, first, I try to factor. If it takes more than 20 seconds, forget it. I'm not going to waste my time. If it's set up for taking square roots, I will use taking square roots. Quadratic, completing the square? Never. Unless you say you can only get credit if you complete the square, then I have no choice, and I'll complete the square. Otherwise, I'll never complete the square. And the last one always works. If I have no choice, that's it. Okay? So, let's use the quadratic formula. Negative b plus or minus b squared. One more time, as I said to the previous class, please remember this must be positive. If I see something like this, I can't give any credit. This is b squared. No matter what b is, positive, negative, it doesn't matter. This quantity must be positive. So we have to start with the positive quantity under the square root. And minus 4 times a times c over 2a. So under the square root, I have 25 minus 8, which is, thank you very much, negative 5 plus or minus the square root of 17 divided by 2. There is no point in simplifying this. Don't waste your time. But I want to show you how to use the graphing calculator, and I always forget. I always start that and I forget. If you want to approximate this with a graphing calculator, you must use parentheses around the top. I also use parentheses around any quantity under the square root. The newer calculators are more sophisticated. They may not need that. But I'm old-fashioned. I don't want to check which type of calculator I'm working with, so I make sure that I have parentheses. So left parenthesis, this is in case you want to approximate. Negative 5 plus the square root. You may have operations in there, so that's why I recommend put in parentheses. In this case, we don't. Close the parenthesis and divide by 2. And press enter. I also need to determine the other solution, and I do this. Second and entry. It copies what I already wrote before, as long as you don't delete every time. And it's easier with the calculator than with my software here to just go back and overwrite plus, change plus into a minus to find the other solution. So one solution is negative 0.438 and the other one is negative 4.562. So I'm going to write approximately because we need this for later for something else. Negative 0.438 and negative 0.438, yes, and negative 4.562. Any questions? Any questions? I'd like to look at a word problem that uses quadratic equations, for which it's a model. We model a situation using quadratic functions, and then we have to solve a quadratic equation. Any questions on any of the 4 methods?
No,
Yes,
I
please.
will say this: my pre-calc teacher had us. Don't remember how I did it, but you can in the newer calculators. I think you can do it. You can program it to where if you have a quadratic problem,
You can put it
you
in.
can just put in A, B, and C, and it would
That's true.
solve it.
That's true. That's possible. Good. Anything else? Other questions, please.
Before we leave,
Yes.
try completing the square again when the
Yes.
middle coefficient is not even.
Yes. Yes, of course. Do you have a problem or do you want me to choose? Okay. Let's choose. Yes. What about 55? Tell me if this is okay. If 55 is what you had in mind. X squared minus 5x plus 6 equals 0. Is this? Good. Perfect. Middle coefficient, please. Just remember, no matter how many examples we do here, if you don't go back and review them and redo them, by Monday you're going to forget the method. right? Always remember that little notebook that I highly recommend. Write in there the method of completing the square, because by the end of the third, fourth week, your notebook will already be like this. And focusing all the information, all these important stuff in one tiny spot, it will just be much easier to access, easier to remember, easier to work with. But if you have everything spread all over the place, it's difficult to find it. So please remember that. Okay, middle coefficient. Negative 5 divided by 2. And now negative 5 squared.
25.
Negative 5 half squared. 25 over? Perfect. This is what we will add, 25 over 4 and 25 over 4. And you can use this extra step if you want to move 6 first. If that's better for you, please do it. It's a very good idea. I've had other students from other classes saying that to me.
It just helps you. It just helps not to cause any problems.
I completely agree. Whatever works, I'm fine. So then x squared minus 5x plus 25 over 4 equals 25 over 4 minus 6. Please complete the square on the left-hand side.
X minus 5 over 2.
Oh, of course. It's right there, right? Good. So now this is 25 over 4 minus 24 over 4.
1 over 4.
1 over 4. Any questions so far? Any questions? We have no choice but do this. How many solutions you have to write? Perfect. So x minus 5 halves equals?
You have to square square root of the top and the bottom.
Correct.
So, would you write 2?
How many solutions we have to write?
2
Okay. I'm expecting something before we...
plus 1.
Thank you. And then the square root of 1 is 1. The square root of 4 is 2. So then x equals 5 halves plus or minus 1 half. So please give me 2 simplified solutions. And the 2 simplified solutions are
X equals 6 over 2.
6 over 2, awesome, which is 3. Great job. And 5 over 2 minus 1 over 2, which is 4 over 2, which is indeed. Great job. Any questions? Is this okay? Okay, let's look at a word problem to see how this works in real life. A pool measuring 10 meters by 20 meters. 20 meters by 10 meters is surrounded by a path of uniform width. So this is the path of uniform width. I have x here, and I have x here, and I have x here, and of course I have x here. If the area of the pool and the path combined, if all this area, they say, equals 600 squared meters, what is the width of the path? In other words, how much is x? Okay, this is a rectangle. What is the area of a rectangle?
Square time, width, height times length.
Length times width, that's fine. So the area is length times width, when the area is given to us to be 600. I need to identify the length, and I need to identify the width. Can anyone give us the length of the pool, including the path around it?
20 plus. 20 plus x, because you're multiplying.
So what is the length? I want to get from here till here. Can anyone give us the length?
20x plus 20? No.
So I have an x here and I have an x here. If I stop here, 20 plus x will be okay. But I don't want to stop here. I can't stop here. I have to go from this till this. 2x.
That's fine.
Very good. That is the length. Perfect. Now, I need someone to tell us what is the width. Indeed. Okay, what type of equation do you think this is? And we are solving for what? Of course, we are solving for x. What type of equation is this? Exactly. How do I know it's quadratic? Because when I multiply 2x by 2x, what do I get? 4x squared. 2x times 2x, I have to multiply the 2's and I have to multiply the x's. Good. Very good. So let's do that. Please tell me, give me the equation now that we need to solve. I'm ready.
4x squared plus 60x plus 200.
4x squared plus, yes, 40x plus 20x plus 200 and minus 600 equals 0. Correct. But we have to see it. You're way ahead of everyone. Excellent.
Does that say plus 200 minus 600?
I have to move 600 to the other side.
Yeah, what's the number right before it?
Yes.
Okay.
Yeah, no, you're right. So one more time. 2x times 2x is 2x squared. 2x times 20 is 40x. 10 times 2x is 20x, and 10 times 20 is 200. And then I had to move 600 to the other side. So in descending order, 4x squared indeed plus 6x minus 400 equals 0. I meant 60 here, of course. Okay. What do you think, since you know me a little bit, what do you think I'm going to do next? Say it again.
Go through the methods.
Simplify by 4. Remember, simplify and factor are the key words in any math class. Simplify and factor. So I will definitely simplify by 4 because I can. And this is x squared plus 15x minus 100 equals 0. Now here's a quadratic equation. I'm not specified which method to use. It may take more than 10 seconds or 15 seconds for me to factor. Completing the square, absolutely not. Taking square roots, of course not. It's not set up. I'm going to go directly to the quadratic formula. Negative b plus or minus b squared minus 4ac over 2a. Do you need me to show with the graphing calculator one more time, or is this okay?
Use straws.
With the graphing calculator?
Yeah.
Okay, so parentheses for the numerator, and we have negative 15. The negative, when we start with a negative, you have to use this symbol at the bottom. Not this symbol, not the operational minus, but the negative. 15 plus the square root. In parentheses, especially when you have an operation, 225. I could have written 625, but let's say we have an operation in there. 400. Close the parenthesis under the square root. Go outside of the square root, close the parenthesis, and divide everything by 2. So we got 5, and then I repeat with second and entry. And I just go back and override the plus. I want it into a minus. And that is negative 20. So we have two possibilities for the width of this path. 5 meters or negative 20 meters? And obviously, we're going to say, no way. A distance cannot be negative. Questions on this word problem? Questions on this word problem? If you encounter other word problems in my math lab, please, and if you have any difficulties, please bring them to class. Take a picture, whatever. Okay? Any questions? Okay, here's where we are. We have 2 more sections from chapter 1. So we'll continue with 1.6 and 1.7. Questions?